All right, so we are reviewing our factoring techniques, which I know we did so awesome on. Factoring techniques, remember, you should always check for the what first? Greatest common factor, GCF, GCF. You should always check for your GCF first. After you check for your GCF, then fingers crossed that it makes it a quadratic, because there's so many more things we can do with quadratics than there are cubics. So the goal for the GCF is to reduce us down to a quadratic. If that's not possible, does anyone remember what our other method of factoring is? Starts with a G. Anyone said grouping? I heard grouping. No, nobody? Thank you. Good job. Grouping. When we can't factor anything out and we're like, oh no, I can't do anything. Don't worry. We still have other techniques. And one of those techniques is grouping. Okay. So, do y'all remember grouping ties with X box? X box is what makes the X fills in the box, but it's undoing the box. So I'm going to model, grouping, and then if someone doesn't get it, then I'll gladly model it as undoing the X box, okay? All right, so grouping means that you're going to take your first two terms and find their GCF, take your second two terms and find their GCF. So we have x cubed minus 3x squared x cubed minus 3x squared plus x minus 3. So you're going to find the GCF of the first two terms. What is the GCF of my first two terms? X squared. What is the GCF of my second two terms? So everyone has a GCF. What is it? 1. So these are what's going to be pulled out. So I take out x squared. When I factor out x squared, I'm left with x minus 3, correct? When I factor out 1, I'm left with x minus 3. So step 1, we group and find the GCF. Step 2, we factor out the GCFs. Step 3 is you find what is their common binomial. My common binomial is x minus 3, and you factor out the common binomial. So we're factoring out x minus 3, and what are we left with? X squared plus 1. Yes, it does. Are we having a little bit of flashback? Any money, everybody? Okay, good. All right, so once you factored it out, to find your zeros, you set each factor equal to 0. So we set each factor equal to 0. So we have x minus 3 equals 0, and we have x squared plus 1 equals 0. On the first one, what do we do to get x by itself? We add 3, so therefore x equals 3. Agree? And the factored form of that is? Did you say x minus 3? Yes. Okay, that one's done. On the next one, what do I do to get x by itself? Minus 1, and I get x squared equals -1. Then what am I going to do? I'm going to square root, and that gives me what? What kind of I? Plus or minus I. So x equals plus or minus I, which means my factors are x plus I and x minus I. Yes? So putting it all together, I don't feel the need, but we have our x, our zeros. Yes? Oh. So we have our zeros. And we have our factors. How do you feel about grouping? Does anyone need to see grouping alternative, aka the box? Yes. Oh, I mean, I don't mind. I'll do it just in case someone didn't want to say it out loud. Alternative to grouping is reverse box. That means that you have the values and you're plugging them in. So you start off with x cubed minus 3x squared, x, and minus 3. And all you're doing is finding the GCF of every row and every column. That's your main thing. So if grouping isn't your friend, you reverse box. What's the GCF of the first row? X squared. What's the GCF of the second row? 1. GCF of the first column. GCF of the last column. -3. If your outside box is negative, your GCF is negative. And what do you get as your factors? X minus 3 and x squared minus plus 1. Did we get the same thing from grouping? Yes. So if grouping isn't your friend, you also have the reverse box. Got it? I left a slide. You need me to go back to example number 7? Oh, in a second I will. All right, so your challenge is to do number 9. I believe in you. All right.
Before I go, Ms. Jones, look what I have.
All right, so up here, this is the one that you're supposed to be working on. It says that the complex number is going to have z equals 2i. And so it tells you that, you know, in the end, you should have a complex with 2i. So using your factoring technique, whether it's grouping or the box method, you should be able to factor this completely. So we're going to group our first term. So we have 4x cubed plus 10x squared plus 16x plus 40. After we group, we're going to find the GCF of each term. The GCF of this term is 4x squared. The GCF between this term is going to be 4. So I factor that out. 4x squared leaves me with x. That's not 4, it's 2. You saw nothing. You heard nothing. This is a 2. 2, 2, 2. Should be a 2. So we're going to factor out 2. I think I wrote something different, but we're going to see where this goes. So we have x squared. Factored it out with 2x squared. We're left with 2x. And then we have plus 5. Then on this one, we're going to factor out 4. And we're left with 4x plus, that's because I can factor out 8, y'all. Guys, see, these extra background noises are making me feel a little off. Oh, Jesus, my bad. Teacher knows. Factoring out 8, joking, was hoping you were paying attention. So we're factoring out 8, 2x plus 5. And then now, what is my common binomial? My common binomial is 2x plus 5. When I factor out my common binomial, what am I left with? I'm left with 2x squared plus 8. Now, step 4, I take each factor outcoming and set them equal to 0. Take the second factor and set it equal to 0. Once we've now set our factors equal to 0, we can now solve for x. So to get x here, we subtract 5 and we divide by 2. So that leaves us with x equals -5/2. On this one, to get x by itself, we're going to have to subtract 8, divide by 2, and take the square root. So subtracting 8 divided by 2, that's going to leave us with x equals plus or minus 2i. -8 divided by 2 is -4. The square root of 4, -4 is plus or minus 2i. Okay, so there are factors. well, now we can write them as factors. So our factors would be 2x plus 5 times x plus 2i times x minus 2i. Okay. And our roots are there. So that's how that would work. All right. All right. Our last example is if for whatever reason grouping isn't your friend, what do we do? And the answer is long division. We do long division. Okay. So when grouping is impossible, then we got to bring back our good old friend long. Actually, you can do synthetic, long or synthetic division. Okay. So with long division, it just helps you remember where your terms are, your variables are, but either way will work. So I'll model with long division. So when I look at f of x equals 3x cubed minus x squared minus 7x plus 5, I notice that I can't do anything. There's no way grouping is going to combine anything. So that's where the long division comes into play. So it says that one of my zeros is x minus 1, which means that x equals 1. So x minus 1 has to be a factor. And if it's a factor, that means it evenly divides into the polynomial. Okay, maybe this, remember, does McDonald's sell burgers? It's the process of dividing. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down is the process that we follow. So you're going to divide your leading terms. So 3x cubed divided by x is going to be 3x squared. After you divide, you then multiply the quotient times your divisor. 3x squared times x is 3x cubed. 3x squared times negative 1 is negative 3x squared. Sorry. Okay, so again, now we're multiplying. After we multiply, we subtract. When you're subtracting, that means you're changing the signs and combining. So change signs. This will cancel. I now have negative 1 plus 3x squared. Well, negative 1 plus 3x squared is 2x squared. And then I'm going to bring down and repeat. So we change my color. So repeat. So now I have 2x squared divided by x. 2x squared divided by x is going to be positive 2x. Yes, ma'am. No, you're good. Positive 2x. And now I'm going to multiply. So I multiply 2x times x gives me 2x squared. 2x times negative 1 gives me negative 2x. After I multiply, I subtract, which means I'm changing signs and combining. Eliminates. Negative 7x plus 2x gives me negative 5x. And then the B stands for bring it on down. So plus 5. After I do that, I'm going to repeat again. So we're negative 5x divided by x is negative 5. Then we're going to multiply. Negative 5 times x is negative 5x. Negative 5 times negative 1 is positive 5. Change signs and combine. And because it's a factor, we get a remainder of 0. So now we're down to 3x squared plus 2x minus 5. So our semi-factored form would be x minus 1 times 3x squared minus 2x plus 2x minus 5. All right. So at this point, you now can factor this. So you should be able to factor this, and you can factor this either using the quadratic, using Xbox, using whichever method you choose most comfortable with, but that's a factoring technique that you decide. I'm going to model really quick with the Xbox. So your A times your C, that's going to give you negative 15x squared, and your B is 2x. So it multiplies to give you negative 15x, adds to give you 2x. those numbers would be a positive 5x and a negative 3x. So when we say reverse box, it's the visual way of grouping. So your leading term was 3x squared. Your last term is negative 5. So you have 5x and negative 3x. So your GCF here is 3x, 5, 1x, and negative 1. So this factors out to become x minus 1 times x minus 1 times 3x plus 5. Okay, so your factored forms, this would be your fully factored form, and it can be simplified to x minus 1 squared times 3x plus 5. And those are your factors. Now that you have your factors, you can easily solve for the zeros if it asks, but it just asks to find the factor. So those are my factors of my function. All right, that's it for 1B.5 part